So remember we said that with any measurement, where we have a population component for that measurement and a sample component. So let's say that for the population, we have a simple data set, just as an example. So let's say that our data set is one, 5, 9. And let's say that in another case, our sample is the same data set, but it represents a sample. So let's say also 1, 5, 9. So in the first case, this data set 159, it represents a population, which is all the numbers you care about. But in the second case, you care about a lot of numbers, and then you randomly select 3 numbers that happen to be 1, 5, and 9, so this represents a sample. So let's go ahead and talk about calculating these 4 quantities here. So the first thing we'll calculate is the population variance, and that's going to be exactly the same as what we just built up over here. That's going to be the population variance is the average square distance of each number from the mean. So in this case, what's the mean?
5.
Yeah, very good. So if you added up these 4 numbers, these 3 numbers divided by 3, you're going to get 5. Or you could also recognize this middle number has the surrounding numbers being the same distance around it, 4 units. So this middle number has to be also the mean. So this is the first number minus the mean squared. We're trying to find the average square distance. So we're taking each number, subtracting the mean and squaring it. So we're adding up these 3 square distances and we're dividing by 3. So this gives us the average square distance. And if you were to calculate this, let's see what this is. So this is -4 quantity squared plus 0 squared, which is 0, and plus 4 squared. And that's divided by 3. So then we're going to get 16 plus 16, which is 32, divided by 3. And this looks like 10 2/3, is that right? Yeah, 10 2/3. So 10.6 repeating. Okay, so that's the population variance. Calculated exactly the same way as we said before. It's just the average square distance from the mean. But the population variance is going to have a mathematical symbol that's associated with it by convention. And that symbol is going to be this. It'll be this Greek letter sigma. It looks like an O with a hook on it. And so this will be sigma squared. Okay, and so if we go to the next component, which is the population standard deviation, what did we say the relationship between the standard deviation and the variance was previously? Yeah, very good. So the standard deviation, we said, was the square root of the variance, and the point of that is to try to undo, at least partially, each of these squarings. While we're summing up, we want to take the square root of the whole thing. So if the population variance is 10.6 repeating, then what is the population standard deviation? It's the square root of that. Very good. So we're going to take the square root of 10.6 repeating, and whatever that is, So if you punch it in, approximately what it,
About 8.265.
okay? And so let's talk about the symbol associated with that. So if the symbol for the population variance was chosen as sigma squared, and the population standard deviation is just the square root of that, then what do you think the symbol for the population standard deviation will be? So essentially, it'll just be the square root of sigma squared. So the square root and the sigma will the square root and the squared will undo each other. So you're just gonna get sigma. So the population standard deviation is just sigma. And that's the reason why the symbol for the population variance was chosen as sigma squared, so that you could have just sigma as the population standard deviation. Any questions? Okay, so now let's talk about the sample variance. So in this case, these three numbers represent a sample or only a subset of the population that you care about. The calculation will be a fraction like it is now, but the big difference is instead of dividing by the total number of data points, you're gonna be dividing by the total number of data points minus one. So that's the only difference. So up top here in the fraction, we're gonna add up all the squared differences from the mean. That'll be the same. And then instead of dividing by 3 data points, you're gonna divide by the number of data points minus 1, which is 2. So if we calculate that, we're gonna get on top 32 divided by 2, so we're gonna get 16. So let's talk about the mathematical symbol associated with the sample variance. So it turns out to be lowercase s squared. So this is the symbol for the sample variance. Yeah, so right now, I just want you to know that that's what we need to do when we're calculating the sample measure variation versus the population one, we're divided by 1. So right now, I just need you to know that. And then if we have time, we can talk about why that is. But it turns out that being this early in the semester, usually when I try to explain why it is, students kind of glaze over. So if you really want to know, stay after class and we can talk about why you have to subtract 1 here. Yeah.
Why do you divide by 3?
What is it now?
Why do you divide by 3, like in the population one?
Oh, so 3 is the total number of data points. So here there are 3 data points. Yeah. So in the sample case, we're dividing by the number of data points, but minus 1. Okay, so that's the sample variance. The sample standard deviation, turns out that, remember the standard deviation is the square root of the variance. So in this case, the sample standard deviation will be the square root of this variance we just found, which ends up being 4. So let's talk about the mathematical symbol. If the mathematical symbol for the sample variance is s squared, what do you think the symbol for the sample standard deviation is? Just s. Okay. So the square root of s squared ends up being s. So now that we talked about how to calculate these measures of variation by hand and what they mean, Let's go ahead and talk about doing it on a calculator. So if you have your calculator, go ahead and take it out. So every calculator is gonna be a little bit different in terms of the keystrokes, but in general, there's gonna be some kind of data mode where you punch in data and then you can enter in the data points in that data set. And so, in this case, you would enter in the numbers 1, 5, and 9 as your data. And then after that's done, then you would go to an option that maybe has something like stat variables. So once you press that, then the calculator will internally use these values into these formulas, and it'll give you these measurements. So in the time we have left, I'm gonna walk around and show you on your particular calculator. Who's ready? I can show you. Okay, good. So using your calculator, then you saw that of these 4 measurements that we talked about, which of the measurements does your calculator give you? Yeah, it gives you the standard deviation. So it gives you this, and it gives you this. So of these 4, it doesn't give you the previous 2. So it doesn't give you this population variance and the sample variance. So how do you think you can find those? Yeah, so now that you have the standard deviations, you can easily find the variances if you need to by squaring these respective standard deviations. So if you square this number, you get this, square this number, you get